Hello class, welcome to our second lesson dealing with section 9.3. This deals with the surface area of cylinders. So we talked about the surface area being two circles and then the circumference times the height, and we had the formula for that the other day. We're going to continue on that conversation and go a little bit more in depth about the circumference of cylinders today. First thing that we want to look at is just a simplifying question. So these both require the distributive property. The key is the negative sign. So actually this one on the right side is a little bit easier for students to solve than the one on the left. This negative 3 needs to be distributed into everything in the parentheses that's separated by addition or subtraction. So negative 3 times 2x is negative 3 times 2 is negative 6, then x. Negative 3 times negative 4, so negative 3 times negative 4 is actually plus 12, and then plus 18 keeps going for the ride. From there, just combine like terms, so positive 12 plus positive 18 is positive 30. And my answer would be negative 6x plus 30, and that's my final answer for that situation. The one on the left side, the most common mistake is not dealing with this minus sign in front of the 2. So really, if you do keep, change, you can make this plus negative 2. And so really, I'm distributing a negative 2. So negative 2 times 8 is a minus or negative 16. Minus 2 or negative 2 times 7x is negative or minus 14x. Combining like terms here, I've got a 9x and then minus 14. So 9 minus 14 would be found by doing 14 minus 9, which is 5. But knowing that the bigger number is negative, so it would be a negative 5x minus 16. And typically you want the part that has the x value first. It doesn't necessarily matter every time, but it's going to help you when you get into some of your algebra topics later on to have that x value with the coefficient first. Okay, we're going to look at this can, just a few different styles of questions. How much aluminum is used to make this can? So that's just surface area because the aluminum's throughout the entire can. So 2 pi r squared. So it's easy here because r is 1. So 2 times pi times radius squared plus 2 times pi times r, and then times the height of 2. Notice here I just plugged in that first. That's the expectation that you're going to do first. You're just going to plug all the numbers into the formula. Then you're going to have an answer in terms of pi, and you can always get a decimal. I'm not going to do as many of the decimal answers here because multiplying by the pi button on your calculator should just be the easiest step. But don't forget you got to square first before you multiply. So 1 squared is 1 times 2 is 2 pi. 2 times 1 times 2 is 4 pi, and I can order this however I want. So I can multiply because of the associative properties and commutative properties in any order I choose, and I get 6 pi inches squared. You could also multiply those two together if you need the decimal answer. Remember, you're going to probably want both on your homework and be able to explain both as you move forward. How much paper is used for the label on the can? So the label is just the lateral area, just around the big kind of rectangle that's being curved. So the lateral area is just the second part of the formula, so that's just 4 pi inches squared, everything but the two bases. The next question says, what if we double the height and width of the can? Now, we did a little bit of this idea when we dealt with area in the last couple chapters, but I think it's good to kind of rehash and relook at it again. So if we just find the answer, okay, just find the answer. So double the width and double the height. So this means the radius would double and the height would double. I plug those numbers into the formula. So 2 squared is 4 times 2 is 8 pi. 2 times 2 is 4, which is the diameter, times 4 the height, and that's 16 pi. And together that's 24 pi square inches. And then the lateral area is just the 16 pi, so it's 16 pi square inches. Now here's what you should notice if you compare them. So you don't want to just assume that this number doubles because that's what a lot of students were saying kind of in our last chapter. So it is correct that something's happening here, but it's not doubling. So if we compare this one, it's 6 pi, and this one's 24 pi. 6 times 4 is 24. If we look at the last one, this was 4 pi for the lateral area. Now it's 16 pi, which is also times 4. The reason that this works is you're kind of doubling length and width. So when I double both, I actually have to double, which is times 2 times 2. And 2 times 2 is times 4, which actually means it's multiplying everything by 4. If I say multiply the height and width by 3, the surface area will actually multiply by 9 because 3 to the second power, or 3 times 3 is 9. If I say make everything times 10, 10 times 10 would be 100, and 100 to the second power would be another way to say that. And you'll end up with 100 times as much surface area as you did before. So just because it doubles, all the dimensions double, it doesn't just double the surface area, it actually quadruples it because it's 2 to the second power. The next question just talks about comparison using proportions. So I'm going to earn 7 cents if you've ever recycled aluminum, for example. They have places that'll take like aluminum cans if you collect them. and then take them in yourself. You can get a little bit of money for them. The diameter is 3 inches and the height is 4 inches. So I'm just going to find the surface area of that. So 2 pi r squared. Remember that if the diameter is 6, the radius is 3. So 2 times 3 squared, which is 18 pi, then plus 2 times 3 times 4, and that would be 24. And I add those together and get 42 pi square inches. How much can I expect to earn by recycling a can with a radius of 2 inches and a height of 6? This one I don't have to divide the radius because it's already given to me. So 2 pi times 2 squared, because the radius is 2, plus 2 times pi times 2 times the height of 6. I find that number is 32 pi. It says the recycling value is proportional to the surface area. Now, typically these things are done by weight or things like that because you can crush the aluminum and reuse it and things of that nature. But this is saying it's proportional to the surface area that I have. So for the 42 pi square inch can of surface area, I get 7 cents, which may not seem like a lot, but it adds up over time, should equal 32 pi over x. Okay, that's what a proportional relationship should look like. I'm just going to cross multiply it, so 32 pi times 0.07, and then equals 42 pi x, and divide by 42 pi on both sides. And it should be less because this can is a little bit smaller in surface area than the other, and you get just over 5 cents, 5.3 repeating cents, but I would probably round that to 5 cents then because it's going to 2 places because it's money. I would try this out on your calculators. Make sure you're able to get the answer. A lot of times students plug in something wrong and they say, my calculator is broken, my calculator is broken. And I say, well, not really. It's because you're plugging the order of operations in wrong as you're looking at some of these questions. So make sure you try that out. Try cross multiplying that and seeing if you can get the 5 cents. I think that'll really help as you deal with proportion questions later on in different classes as you move forward. This is just a review of two-step equations. So $35 to rent a truck, so like a moving truck, for example, and 75 cents per mile. No sales tax right now. If we have to deal with sales tax, we'll deal with that later. How many miles do I drive if the total was $71? Your goal is to write and solve an equation. So what's unknown here is the number of miles. So I define my variable. X is the number of miles driven. $35 is a set cost. So no matter what, it's going to be $35 plus 75 cents per mile times the number of miles equals $71. I subtract 35 on both sides. I get 0.75x equals 36. Divide by 0.75 on both sides, and I'll end up with 48 miles as the final answer. Please make sure that you understand how to deal with the two-step equation here. We've been doing these a lot throughout the semester. It's an important skill to make sure you understand as you move to your next class. And so that's why we keep bringing it up. Define the variable, write the equation, show the steps, find the answer to the equation. Okay, now using that same idea, we just figured out it's going to be 48 miles. So the question is, well, how much gas am I going to have to put into the car? So I'm sure many of you had conversations at some point about gas prices and things of that nature. So this question here says, the truck gets 7 miles a gallon. So the first step is to figure out how many gallons do I need. I can do that easily by taking the number of miles I'm driving, which is 48, dividing by the miles per gallon, or MPG, and I get 5.3 repeating gallons. Now, you don't want to round that answer because that's really 5 1/3 gallons. When you're plugging things into a calculator in this nature, leave that whole answer there, and then each gallon costs $2.75, so multiply that by $2.75, and then at the end you round to the nearest hundredth. Okay, so that would be $14.67. So when you're looking at these questions, don't round to the very end. Remember, miles per gallon can be divided by the number of miles to figure out how many gallons you have, and then multiply that by $2.75 to figure out the total price. Okay, your homework today is 6 through 13 and 16 and 18 in section 9.3. Remember, this is section 9.3, which is surface area of cylinders. You need to draw some nets out on numbers 6 through 11, just like what we did the other day. We didn't draw any nets specifically today to get them started, but I think the nets of a cylinder are much easier because it's just the rectangle and the 2 circles on the ends. Pay attention if you want to have 2 circles or 1 circle or no circles. Okay, and make sure you're making a formula sheet and starting to memorize some of these formulas and understanding how to use them at different times. Have a good day, everyone.